The ultimate load capacity of a 10-meter long concrete pile of square cross section 500 mm by 500 mm driven into a homogeneous clay layer having undrained cohesion value of 40 kPa is 700 kilonewton. The ultimate load capacity is 700 kilonewton. If the cross section of the pile is reduced to 250 mm by 250 mm and the length of the pile is increased to 20 meter, the ultimate load capacity will be. So the cross section of the pile is reduced from here to here and the length of the pile is increased to 20 meter from 10 meter. So if the given dimensions in the case 1 10 meter and 500 mm by 500 mm, the capacity is 700, whereas the dimensions are changed, then the new capacity will be how much? This question is from 2010 gate paper, question number 39 and containing 2 marks. So first, so let us write down the given data. In the case 1, what is the length of the pile? L. Length of the pile L equal to, let us say this is L1, that is given as 10 meter, and the width of pile you can say B, as it is case 1 B1 we will write that is 500 mm 0.5 meter, right, and the capacity is Q1, that is 700 kilonewton. So in case of second, the length L equal to L2 is 20 meter, right? If you want to write L2 in terms of L1, see L1 is 10 meter, L2 is 20 meter, that you can say 2 into L1, right? And length is over, then width B is B2, that is 250 mm or 0.25 meter. So that can be written as, here B2 can be written as in terms of B1. So this is B1 by 2 because 250 mm is half of 500. So that's over. Then Q2 is the required capacity to be calculated. It is to be calculated. Then, so going for the case 1 again and case 2 here. In the case 1, let us first of all let us write capacity equation, capacity of the pile equation. End bearing resistance plus frictional resistance. Okay, the capacity imparts from these two capacities, then that can be written as area of the bearing multiplied by CNC plus surface area multiplied by alpha addition factor into undrained cohesion. This is for only clays. Okay, Q clays. So average shear strength, sorry, average cohesion over the depth multiplied by alpha addition factor multiplied by surface area. So this is the formula. So in the case of first case, so Q1, right? This is Q1. You can say AB1. Cohesion is common. This bearing capacity factor is common. You can write undrained cohesion. Then surface area AS1 into this is common, and average cohesion is also common for the two cases. So I'll go for second case. Second case is Q2. So AB2 multiplied by cohesion is common, NC is common, plus AS2 multiplied by alpha into Cu. Okay. Now keeping this, I just want to calculate what is AB1, then what is AB2, and AS1 and AS2, right? Going back to question, this is the square cross section pile. Let us draw first square cross section. In the front view you can see this, then in the front view you will not be able to tell, but whose length is L, whose, it can be diameter or it can be square cross section. So if you go for square cross section, if I want to show you in 3D diagram, then I can show like this. This is ground. Okay. Right. So this is B. This is square cross section. This is B, and this is L. Right. So what is AB? AB is bearing area. B. So AB will be B square. What will be the A surface area? Surface area is this, four sides. So perimeter 4 into B into 4 into B, because there are four sides, 4 into B is perimeter. The perimeter into height 4BL. So 4BL, that is AS, right? So now substitute these two, AB equal to B square, AS equal to 4BL. Here AB is B square, sorry, B square, this is 4BL, whereas B square is B1 square, because AB1, that is B1 is 0.5 square, and 4B1 into L1. Okay, let us keep it like this, or else you can substitute 4 into 0.5 into 10 meter. So this is AS1. Now what is AB2? B2 square, right? So what is B2? 0.25 square. What is AS2? 4 into B2 into L2. Okay, I have written B2 in terms of B1. So B1 by 2, I can write B1 by 2 here. In place of L2, I can write 2L1. Okay, so now 2 gets cancelled, 4B1 L1. So this is AS1. So AS2 is equal to AS1, but AB2 is not equal to AB1. AB2 is 0.25 square, AB1 is 0.5 square. So coming back to the equations for the capacity, we'll substitute these values in this equation. So I'll be again case 1, case 2. Okay, in the case 1, so I'll rewrite this Q1 equal to AB1 into CNC plus AS1 into alpha Cu bar. Okay, and this one Q2 equal to AB2 into CNC plus AS2 into alpha Cu bar, right? So substituting these values, in place of Q1 it is 700 given, AB1 is 0.5 square, CNC is, let us C equal to 40 kPa, C equal to 40 kPa, Cu. Okay, Q1 is 700. Here it is written. So in the given data, I should have written this 40 kPa also. That is common anyway. Cu2 is also 40 kPa because that is common. That's why I didn't write. Okay. Now coming back to this, AB1 is 0.5 square, C is 40, NC for the clays in deep foundations or pile foundation will be 9. Then AS1 is how much? 4B1L1. 4 into 0.5 into 10. Okay. So let us write in, for the timing you can write AS1 as AS1, then alpha as alpha. We don't know, that is not given in the question, and Cu. Now again Q2. AB2 is 0.25 square, C is 40, NC is 9. Okay. Plus AS2 is nothing but AS1. We have proved it. AS2 is 4B2 into L2, 4B1 by 2 into 2L1. So it is finally equal to AS1. Okay. You can write AS1 into alpha Cu bar. Okay. This term and this term are same. Right. So that's why I did not substitute the values. Now, if you want to find out this term, you can directly put it in AS1 alpha Cu bar equal to 700 minus 0.5 square 40 into 9. So you can find out this 700 minus 0.5 square into 40 into 9. This is 610. So this AS1 alpha Cu. You can write this as QF also because frictional resistance, this is bearing resistance, this is total resistance. Okay. So finally, how much did I get? QF as 610, right? So this and this are equal, then this I can write 610. So Q2 equal to 0.25 square 40 into 9, sorry, plus this is plus 610. So if you find out that 0.25 square into 40 into 9 is 22.5 plus 610 equal to 632.5 kilonewton. Okay, Q2 is 632.5 kilonewton. Let us go back to the question. 350 kilonewton, 632.5 kilonewton, 722, 1400. So answer is D. Thank you.